Hello, my name is Maggie Welch, and today I'll be presenting on Chapter 3's topic, Owl Hearing, IID and ITD. IID is interaural intensity difference, and ITD is interaural time difference. IID is the difference in loudness of sound when it reaches both ears, and it determines elevation, so on the vertical plane. An inherent problem that you have is that the head creates a natural barrier, so a sound shadow, where IID cannot be determined. To help with this, an owl's ears face in the opposite direction, so the right ear faces upwards and the left ear faces downwards. ITD is the difference in the time it takes for sound to reach both of the ears in a horizontal plane, and the size of the head helps determine ITD. It determines azimuths, so on the horizontal plane. Some inherent problems that you have are phase ambiguity and jitter. The neurons in the magnocellular nucleus phase lock, but they don't fire at every phase, so this creates phase ambiguity. For jitter, neurons in the magnocellular nucleus don't always fire at the exact same phase every cycle for the sound wave, and these are resolved via connections between ICCIS and the external nucleus of the inferior colliculus, or the ICX. To calculate the maximum ITD, we can look at this problem right here. So for the minimum ITD, it's when sound is directly in front of the owl. So when sound is at 0 degrees, that's when the sound is going to reach both of our ears at the same time. So ITD would be 0 is the minimum. The maximum would be when sound is directly to the right or directly to the left, so when sound is at 90 degrees. To calculate maximum ITD, you can use the formula max ITD equals the size of the head divided by the speed of sound. So we can see the size of the head for the owl is 0.2 meters, and the speed of sound is 343 meters per second. So that comes to be 0.58 milliseconds is the maximum ITD, and as I said before, the minimum ITD would be 0 when the sound is directly in front of the owl. Here we can see the ITD pathway in orange and the IID pathway in blue, and how they converge in the ICCIS in green. IID is computed via spike frequency in the angular nucleus, so NA, which is in the cochlear nuclei, and the contralateral inhibition of LLDP. ITD is computed via the Jeffress mechanism between the magnocellular nucleus, NM, and the laminar nucleus, NL. There are coincidence detectors in NL, and they use delay lines in order to calculate ITD.